Hello, everybody. I hope everybody's doing okay. This week we're going to take a look at starting chapter 7. I skipped over one of the sections in the last chapter because, well, simply it's not used too often in math. It's not used too often in going forward in our book. And, well, learning's hard right now in the current situation, so I figure anything that we can reasonably skip, we probably should, so we can focus on the more important things you're going to be needing for next year. Okay, so chapter 7. Chapter 7 deals with what we call systems of linear equations, or just systems. Okay, so far in math this year, we've been dealing with problems that have a single linear equation, just one. Okay, but today we're going to take a look at when we have more than one. So what I'm going to say is when we have more than one equation, more than one equation which involves the same variables, it's known as a system of equations. Okay, so just so we're clear, we have something like, y equals 2x plus 1. On its own, that would just be an equation. But if we had something else, like y equals 3x minus 2, together, they're a system of equations. In this case, they're linear equations because they're both in y equals mx plus b slope-intercept form. Okay, so more than one equation, we call it a system. All right. So the main idea here this year is we're going to move towards solving these systems of equations. We're not going to do that for the first few sections. We need to be able to do a few other things first before we worry about solving them. Okay. Um, but we're going to talk about solving them first. So a solution to a system are values for each variable that are in the equations. Each variable. That satisfy the equations. So for example, a solution would be x equals something and y equals something, okay? Because we have x and y in both of those first equations. So we need to have some number, some value that each of them are equal to both x and y together. Okay, so that's what a solution would look like for these linear equations that we call a system when they're together. Okay, so that's sort of the introduction to the main idea behind what we're going to be taking a look at in this chapter. This section in the chapter, 7.1, deals with being able to develop your own systems to describe a situation. Okay. And unfortunately, that's probably the hardest thing to do on your own. So we're kind of starting with the hardest part here, but it's kind of the first thing you're going to have to be able to understand before we can move on to doing, um, higher level questions with this content. Okay, so let's do an example and I'll kind of show you what I mean. So we'll say, example, create a linear system to model the following situation. Okay, the perimeter of a flag is 16 meters. Its length is 2 meters longer than its width. Okay, so that's our situation. So we're being asked to create a linear system. So what that means is we're going to be coming up with at least two individual equations. For the most part, you're only going to have to do two. We're not going to see too many situations in this course where we're going to have to do more than two. Okay, so we can make a sketch. Obviously, our flag is going to be rectangular. We have some length, I'll call it L. We have some width, I'll call it W. So it'd be a good idea here. Let L equal the length. And let W equal the width. Okay, and this is probably the most important part when it comes down to developing your own system of equations. You're going to have to come up with two variables, usually two variables, sometimes you might need more, that represent something that applies to all the pieces of information that you know about the situation. So what are the two pieces of information we know from this situation? The first one is that the perimeter is 16 meters, and the second piece of information is that the length of the flag is 2 meters longer than its width. Those are the two pieces of information that we know. So we have to think, what are some variables, what are some values we know that deals with both the perimeter and the length and the width? Well, the length and the width. Of course, the length deals with the length, and the width deals with the width. So that covers that idea. And the second idea of the perimeter, well, we know that we can get the perimeter just by adding two of the lengths and two of the widths together. So length and width deals with both of these two separate ideas, that the perimeter is 16 and that the length is 2 meters longer than the width. Okay. That's going to be the hardest part of these questions, is trying to come up with what variables you're going to need to use. And there's no real easy way to teach that, just because it differs so widely from situation to situation. but in this case, it's going to be length and width. Okay. So let's deal with the first piece of information we got from this this scenario. We're going to come up with our first equation in our system here. So the perimeter of the flag is 16 meters. So we need to set up an equation that describes that. Okay. So perimeter. Well, we know the perimeter is just given by adding up all the sides, right? And of course we know that this side is equal to this side, and this side is equal to this side. So whatever the length is, we're going to add one length, we're going to add two lengths for both sides, and then we're going to add two of the widths to get the perimeter, right? And of course we can simplify that to 2L plus 2W. Okay. And, well, we know that the perimeter is 16 meters. So we know that 2L plus 2W equals 16. Has to. We don't know what the length is. We don't know what the width is. But we know as long as we add two of each of them together, it has to add to 16. So this is going to be equation 1 in our system. Okay, so notice there's only L and there's only W. There's no other variables there. Okay, and now we can make an equation for the second part. The second piece of information, which is the length is 2 meters longer than the width. Well, how would we write that in an equation? So, well, what's longer? Its length is 2 meters longer than its width. So we know the length is going to be longer. So to write that as an equation, we would say that the length is equal to the width plus 2 meters. That's it. Take the width, add 2, we get the length. That's what it's saying. And that's it. There's nothing else we have to do. That's an equation. It has just L, it has just W, it has an equal sign, so it's an equation. That's equation 2 in our system. That's it. Okay. So what I'm going to say here is we have two equations, and they're both linear. And, well, if we have more than one equation, we know we have a system. Right? So our system is 2L plus 2W equals 16, and also L equals W plus 2. Okay. Sometimes you'll see systems written like this with a little curly bracket on the side. That's fine. Okay, so that's our system. So what we're going to do now is we're going to talk about a solution to this system. So we'll say I measure the flag to be 5 meters by 3 meters. So a length of 5 and a width of 3. And what I'm going to say is use your system that you developed in the previous section to verify these measurements. Okay. So what I'm saying here is, okay, it's proposed that the length of the flag is 5 and the width of the flag is 3. So what that means is, if we were to substitute those values into the systems that we just made, are those equations, both of them in the system, going to be satisfied? And when I say satisfied, I mean, is the left side going to equal the right side? Okay, so let's go in and check. So we'll check our first system. So that's 2L plus 2W equals 16. Okay, so just to be clear, that's my length, that's my width. Okay, length, width. So I'll come down and make my substitution. I said the length is 5. And I said the width is 3. All right, and now we can do the bed mass here. So 2 times 5 is 10. 2 times 3 is 6. 10 plus 6. 16 equals 16. Does the left side equal the right side? Yes, it does. It's true. Let's try the second one. L equals W plus 2. So again, make the substitution. L is 5. Whoa, what happened there? And W is 3. So we have 5 on the left, and on the right we have 3 plus 2, also 5. Does 5 equal 5? Of course, yes it does. True. Okay, so what we've seen here is both equations from the system are satisfied. Okay, so we're happy. Okay, so we know that that system of equation accurately describes the situation that we have here. Okay, so I think that's all we're going to go over for today, or for this week, I should say. So the homework for this week is going to start on page 401, and I'll have you do questions 5 to 7. So we'll do 5, 6, 7. All right. So stay safe out there, everybody, and we'll see you next week. Bye.